So today's session is gonna be about Spark. So basically, Spark architecture, as I told you yesterday, it deals with massive. So basically, Spark architecture is a distributed system. The main idea is to process the data in parallel. So massive parallel processing happens.
Okay.
That is the whole idea, but we will be going in detail at each level. So the components of Spark architecture, it consists of, initially there will be a cluster manager. There will be a distributed storage system, like how we saw yesterday, DBFS, Databricks first, and a set of computational engines. These computational engines are the clusters that we saw yesterday. Okay, now you will see the role of each. So cluster manager, the role of cluster manager is to, basically we have the computational storage and the computational engine. So basically, role of cluster manager is to allocate the resource. Say in the computational, in the cluster yesterday we saw we have multiple nodes, and to manage all of these nodes, as in how much that the role of cluster manager is to manage this the computational engine.
Okay.
Yeah, and then we have distributed file system. So distributed file system, it provides a fault tolerant and scalable storage layer for processing by Spark. So fault tolerance is very important for database. Okay. I don't want to deviate from the topic, but once we cover these three topics, I'll talk about fault tolerance.
Okay.
Then the other thing is, so that's about distributed storage system. It's nothing but it provides fault tolerant scalable storage layer for processing the data, and this the Spark can integrate with a variety of distributed storage system. It could be Hadoop file system, Amazon S3, Azure Blob Storage, anything. Then the Spark core. I'm going to talk about computational engine. So it has a set of library for machine learning, graph processing, etc. And then and using the computational engine, we could schedule jobs to run our notebook. And the computation engine also provides fault tolerance. And another important thing about Spark architecture is the main data structure of Spark architecture is resilient distributed data structures. So resilient distributed data set, RDD. Okay, it's nothing but it's it's a collection of data, and it can be processed in parallel.
Okay.
Across multiple nodes. So if we have a huge, say, if we have a data set that's huge, it could be divided into multiple set and sent across multiple nodes. So each node can provide the output and then send it back. So and this is also immutable and fault tolerant.
So this is the internal storage where all the calculations are done, is it?
This is the basic data set. As in, how do I put it? Yeah, you can say it as internally what is happening, but say now we are dealing with a data frame, right? This data frame is derived from RTD. So that is resilient, it is immutable and fault tolerant. So basically the overall idea of Spark architecture is to enable scalable, fault tolerant data processing using combination of distributed storage, distributed computation, in-memory caching. Yeah, and Databricks provides in-memory caching. That is why the processing speed is faster. Okay. Now coming to fault tolerance, and important points: fault tolerance and provides in-memory caching. So say, what is in-memory caching, if you ask me? Say one thing, what RTD does is different. The data will be spread across these storage spaces, processed in parallel, and gives us the output. In-memory caching, on the other hand, say if we are using a data frame in multiple places. Okay, so in that case, we could cache that in memory and then do computations on the data frame, rather than whenever we are calling the data frame to get distributed and then process it again and then give us the output. We will cache it in memory and then use it.
Okay.
Yeah. So that's about
Wonderful.
in-memory caching. Then coming to fault tolerance. So for so for fault tolerance, it provides by fault tolerance by using the RDD distribution. So what means is, this RDD, they will be partitioned across in our whole structure. We will have cluster manager. Okay, that manages all the computation engine, all the nodes and executors, all of that. And then we will have worker nodes. Okay, again, once again I can. So we have cluster manager, then we have driver node, then we have worker node. Okay. Now what happens is, inside the worker node we have executors,
Okay.
and inside these executors there are cores. Okay, and each worker node will have some amount of storage associated with it. Okay, and the RDD goes inside this storage. So what happens is, when we fire a query, it goes into cluster manager. Cluster manager then manages, okay, what all how many worker nodes should be associated with it, all of that, and then it gives the query to the driver node. Driver node, what it does is, it distributes that the whole code across multiple worker nodes. So whenever so inside worker node, there will always be some executors that are vacant, as in some executors that don't have work. So the driver node divides the work across multiple worker nodes as per the instruction from cluster manager, and then this worker node, it processes that inside the worker node also. There will be multiple executors, and inside the executor, these cores takes up this task, and then it processes the data and gives the output back to driver node. The driver node consolidates this output and gives us the final result. So that is the whole story. Now coming back to fault tolerance. So now the RDD, what happens is, this RDD will be spread across multiple worker nodes. Then what happens is, so when I say that this RDD is distributed across multiple worker nodes, there will be multiple partitions of data, and each partition will be replicated in multiple nodes. Why, if you ask me, say one node were to fail, to prevent that, there will be replication. So partitions are replicated. So what happens is, whenever if any node fail, so since the partition is spread across multiple nodes, whenever a node fail, it can still recover, because it is replicated in other nodes as well. the partition of data. Yeah. Then Databricks does something called lineage. So like I said earlier, RDDs are immutable. Say if we do multiple transformations to one RDD and finally we create another, we do transformation and refer that to, as in put it in another RDD. If we do all of that, it maintains a lineage. So even if if there is a failure at any point in time, database can refer this lineage and recreate the RDD from that point. Then there's the key components of Spark architecture. So see, we have already discussed what is cluster manager. It's for managing and allocating resources across the Spark cluster. Then we have worker nodes. So worker nodes are what executes the Spark computation. So yeah, then we have executors. Executors run on the worker nodes, and these are responsible for executing tasks assigned to them. Yeah, and each executor, it is responsible for managing a set of tasks and keeping data in memory for faster access.
Okay.
Then we have the driver program. Driver program is the main program that controls the flow of the application. So it runs in a separate node that's different from the worker nodes. Then we talked about RDD, the fundamental data structure. It is immutable and it can process parallelly across the cluster. Yeah, that is about. And then Spark. Then we have two more things like Spark SQL and Spark streaming.